Every year, the citrus industry generates over 30 million tons of orange peel waste globally.
Most of this waste ends up in landfills, creating environmental problems. But innovative companies have discovered a revolutionary solution. The process begins at the waste reception station. First, the peels undergo initial sorting to remove contaminants.
Next, they're thoroughly washed to ensure purity for processing.
Clean peels are essential for producing high-quality bioplastic. The cleaned peels are then mechanically shredded into smaller particles. This increases the surface area for more efficient extraction.
The facility can process up to 50 tons of orange peels daily.
Now begins the most crucial step: chemical extraction.
D-limonene, a valuable compound, is extracted first using eco-friendly solvents.
The extraction process separates oils, resins, and cellulose fibers.
Quality control ensures each batch meets pharmaceutical-grade standards.
Centrifugal separation refines the extracted compounds further. The D-limonene is stored separately for use in cleaning products and fragrances. But the real magic happens with the leftover cellulose material.
This cellulose will become the foundation of bioplastic.
Enzymatic treatment breaks down the cellulose into usable polymers.
These natural enzymes act as biological catalysts in the conversion.
Precise temperature and pH control ensures consistent polymer quality.
The transformation takes approximately 12 to 16 hours. Skilled technicians monitor every stage of the bioconversion process. Filtration removes impurities, leaving pure biopolymer solution. This solution contains the building blocks of bioplastic. Polymerization bonds the molecules into long plastic-like chains. These molecular chains give bioplastic its strength and flexibility. Natural plasticizers enhance the material's workability and durability. Heat and pressure complete the polymerization reaction.
The result is a viscous bioplastic material, ready for forming.
Extrusion shapes the bioplastic into pellets or sheets. These pellets can be used like conventional plastic in manufacturing. Or formed into thin films, perfect for packaging applications. Each batch undergoes rigorous testing for strength and flexibility.
The bioplastic matches or exceeds traditional plastic in many applications.
But unlike petroleum plastic, this material fully biodegrades.
In industrial composting, it decomposes in just 90 days.
The finished bioplastic is ready for manufacturers worldwide.
From here, it travels to companies making sustainable products.
Packaging, consumer goods, and automotive industries use this material.
Injection molding creates complex shapes from the pellets.
Food containers made from orange peel waste are now market reality.
The film wraps products with the same efficiency as conventional plastic. In agriculture, bioplastic mulch film enriches soil as it decomposes.
Even the fashion industry is embracing orange peel-based materials.
3D printing filament offers creative applications for designers.
Car manufacturers incorporate it into interior trim and panels. This circular economy approach transforms waste into valuable resources.
Production generates 70% less carbon emissions than traditional plastic.
And uses 40% less water in the manufacturing process. Millions of tons of organic waste are diverted from landfills annually.
And despite cheap diagnosis, the technology continues to evolve with ongoing research.
Scientists are developing stronger, more versatile bioplastic variants. New formulations target specific industry requirements. Computer modeling accelerates the development of next-generation materials. Pilot facilities test innovations before full-scale production.
The technology is scaling globally in citrus-producing regions.
Investment in bioplastic infrastructure is growing exponentially.
Strategic partnerships ensure reliable waste supply chains.
Some facilities integrate juice and bioplastic production on-site.
Production costs are approaching parity with petroleum-based plastics.
Consumer demand for sustainable packaging drives market growth.
Third-party certifications verify environmental claims and biodegradability.
The environmental advantage becomes clear over time. Bioplastics offer hope for reducing ocean plastic pollution. Marine life faces less danger from materials that naturally decompose.
Water used in processing is continuously recycled and purified. Renewable energy powers most modern bioplastic production facilities.
Smart systems optimize energy use throughout the production process.
Waste heat is captured and reused, maximizing efficiency. The goal is zero waste manufacturing, with every byproduct utilized.
Remaining organic matter becomes high-quality agricultural compost.
This compost returns nutrients to the soil, completing the cycle. The same land that grows oranges benefits from the waste it produces.
Educational initiatives inspire the next generation of green innovators.
Academic partnerships drive continuous innovation in the field. Hundreds of patents protect and advance bioplastic technologies.
Government policies increasingly favor sustainable material production. Financial incentives help bridge the cost gap during market transition. Single-use plastic bans create urgent demand for alternatives.
Major corporations pledge to eliminate petroleum plastics by 2030.
Efficient collection networks secure consistent raw material supply.
Premium peels with high oil content yield superior bioplastic.
Production planning accounts for seasonal variations in waste availability.
Advanced storage techniques enable continuous production year-round. Drying and stabilization prevent degradation during storage.
Research explores using lemon, lime, and grapefruit waste similarly.
Each citrus type offers unique properties and advantages.
Blending different sources creates customized material properties.
Spectroscopy verifies molecular structure and purity levels.
Thermal analysis determines suitable application temperature ranges.
UV stability testing predicts outdoor durability performance. Oxygen and moisture barrier tests ensure food safety compatibility. Antimicrobial properties provide natural protection in certain applications. Regular audits maintain certifications for food contact materials. Compliance with ISO and ASTM standards ensures global marketability.
Industry exhibitions showcase the material's versatility to potential clients.
Sample programs allow manufacturers to test before committing to orders. Technical teams help clients optimize bioplastic for their processes. Custom formulations meet unique industry-specific requirements. Success stories span packaging, textiles, agriculture, and consumer goods.
The industry creates employment in traditionally agricultural communities.
Training programs develop skilled workforce for sustainable manufacturing.
Investment extends beyond factories to support entire communities.
Farmers gain additional income by supplying waste to processors.
The future promises bioplastics in electronics, medical devices, and construction.
Medical-grade variants show promise for biodegradable surgical implants. Enhanced formulations meet stringent electronics industry safety standards. Construction composites blend bioplastic with natural fibers for strength.
Life cycle analysis confirms genuine environmental benefits over alternatives.
Carbon footprint is 65% lower than petroleum plastic.
Industry projections show tenfold growth within the next decade. Billions in investment signal confidence in sustainable material future.
From waste to resource, the circular economy becomes reality. Orange peel waste, once a problem, now powers a sustainable revolution. The transformation from peel to plastic proves innovation can solve environmental challenges.